our customers. You know, hearing the problems that they're facing, we're hearing about their deployments. We understand, you know, the business challenges that they're trying to tackle. So we can sort of evaluate that feedback, make sure we're driving it back to the core team who's doing the vNext development. But it also gives us opportunities like this to put together presentations based on what we've been hearing recently. And a topic that's been coming up over and over again recently, I guarantee you I'm not out of time yet, is that around the scalability story of the AppV management server. So before we get started, I just want to sort of get a feel for who's in the room here. So show of hands, who here is already using AppV in the organization? Good number. The people who aren't already using AppV, how many people are considering or planning, thinking about maybe everybody else? That's good. For the people who are neither, anything in particular I can help you with? Because I'm not, I recommend some restaurants. So the folks that are using AppV, how many are using the management server today? Good percentage, nice. Anyone here who is using AppV but is using some other means to push out their application, not using the management server? Good. Given the title of the topic, that's probably good. Of the AppV folks, and I promise I'll stop polling you soon, of the AppV folks, how many people have been around since the company was called Softricity? A couple of holdouts, very good. I actually interviewed with Softricity before they were acquired by Microsoft. Again, love the team, love the technology. Had this crazy idea that instead of working there, I decided I was going to start my own game company, despite complete lack of money and or wherewithal to do that. So after I turned it down, about a week later, they announced that they were being acquired by Microsoft. So go me. So for the Softricity folks, here's my chance to give away my first prize, possible answer to a trivia question, though I'm telling you it's not going to be easy. Anybody tell me what the name of the company was before it was Softricity? No hand. What's that? Ooh, what? What was that? Wow. Give that man a hand. Software wow. Excellent. Nobody knows that. For that, sir, you don't get one of these pitiful prizes. You get the last cow. Congratulations. Yep, software wow. Minor piece of trivia, if you look through the application logs and you ever see references to components that start with SW, like SW application, software wow. Okay, enough history. Final piece of information I want to get from you guys before we get going. So the people who are using AppV, the people who are using the management server, roughly, how many users is your deployment supporting? Shout them out. 5,000? 2,000? 6,000? So thousands. All right, okay. How many applications are we talking about? 550? Anybody else? 1,500? Nice. 3,000. Okay. I have 3,000. Anywhere else? 3,500. I'm not a Barker. I cannot do that. Okay, cool. So the sort of theme that we were hearing from the customers that drove us to put together this presentation was we started hearing questions around those numbers, particularly in how they're going to change over the future. People were asking questions like, I've got one server today. How many servers do I need to support? 10,000 users, right? I've got 1,000 applications in deployment today. I expect to triple that over the next 18 months. Can my existing infrastructure handle that, or do I need to go out on a spending spree? Those are the questions that we've been hearing. So the goal of this session is to sort of put you in touch with the data and the resources that you need to make informed decisions about your deployment. So how are we going to do that? Got my clicker. How are we going to do that? Session overview. We're going to start, since I sort of like the traditional 3-act formats for my drama, though I hope this isn't too dramatic. We're going to start, we're going to introduce the characters. We're going to talk about the management server. What are the components that make up the management server? How do they fit together? What's the overall architecture? Just sort of basic introductory material. And again, if you're using the management server, hopefully most of this is review. If not, this is a great introduction. And I hope it'll help as you sort of make your ongoing AppV decisions. Keep going. Why is forward on the left? Next, we're going to talk about the fundamental operations that the management server provides. So once we sort of identify what I mean when I say the management server, because that's sort of an inchoate topic, we're going to talk about what this management server infrastructure actually does. And we're going to identify those key operations. And really, there's a handful of operations that the management server does. It's not a real multifunctional platform. There's a very small number of specific things. We're going to take each of those and we're going to drill down pretty deep. We're going to break them down in terms of when I do X, A, B, and C happens. And then we're going to talk about the implications of what those operations have on your infrastructure and the overall performance and scalability of that infrastructure. Okay? And then finally, to sort of tie it all up and augment the now genius level information you have about the management server and how it works, I'll give you some additional directed guidance in terms of sample numbers that we've seen in our scalability tests, some best practices. As I walk through and look at some of the individual operations, I'll point out interesting configuration parameters or specific things you need to consider at that point. I'll wrap it all up at the end so you have it all in a nice table. So the idea is that you can sort of take this deck back and use it as a reference. These aren't just talking points. Hopefully this will be a good resource for information going forward that you can use. And it's pretty. It has nice colors. That's about it. Maybe if I hold it upside down, then forward will be on the, see that? Ladies and gentlemen, I'm an engineer. Okay, so first we're going to talk about the management server infrastructure. What makes it up? What's it for? But before we even get into that, I just want to do a brief sort of overview for the people in the room who don't know a lot about AppV. This is AppV. This is what it's for. These are the problems that it solves. Okay? Pretty quick. I won't spend too much time here. I'm not a sales guy, as you can probably tell by my refined presentation style. So what is AppV? Put pretty plainly, and you can read through this. If you've been through any of the other AppV presentations, you've seen this exact slide, so I'm not gonna read it to you again, but put simply, AppV provides a way for you to take a classic desktop software application and convert that into a virtualized, network-available service. Okay? Classic application to software as a service. How do we do that? There's basically two pillars of the technology that implement that strategy. So first is virtualization. Virtualization is the mechanism whereby we can package up an application and have it run in its own isolated environment, right? And when I say isolated, I mean isolated both from the underlying operating system as well as from other applications that are running on the machine. So it really does have its own view of the world in terms of its peers and its host operating system. Well, why is that important? App compat testing is pretty significant cost when it comes to deploying new applications, right? Who's ever rolled out an application and it's caused some bizarre problem with another application you had already deployed? Ever. Liars. By running these virtualized applications in their own virtualized environments, we can remove, in most cases, completely eliminate, and in a lot of cases, dramatically reduce the number of application conflicts you're going to run into when you deploy those applications out to your enterprise. Let me give you an example. A colleague of mine likes to tell a story about, you're familiar with HTML help? The old Windows help file format. You'd open up the help file, and it would draw on the book for a second. I don't know what that was all about. And then it would show you it's a help file. So the authoring technique for those files was you would create an RTF document in Word 2. It had to be Word 2. Save that RTF file, import it into the help compiler, what have you, out would come your help file. You used Word 3, wouldn't work. 4 wouldn't work. They eventually fixed this, but for a while you had to use Word version 2.0 if you wanted to author these help files. If you know anything about Office, Word, they don't like to sit side by side with one another. Word 97 and Word 2010 don't want anything to do with one another on the same machine, right? Word 97 is there, you install Word 2010. Word 2010 will say, oh, look, I'll upgrade this for you. You're welcome. AppV solves that problem. Since these applications are isolated from one another and really don't know that each other are there, that app compat conflict is gone. So you can run Word 2.0 if you really want to. I don't recommend it. 2010 is a wonderful product. So that's virtualization. Second aspect is software as a service. Since these applications are virtualized, they're never installed on the desktop. The AppV management infrastructure will instead publish what are basically hints to the computer that you're targeting. Shortcuts, file type associations, the same extension points or the same hooks that a user would normally use on a client machine to start up these virtual applications, right? However, since this, the software in question isn't actually installed in that machine, the user just double clicks on a Word doc like they're accustomed to doing, we're not actually running Word, right? We're invoking the AppV client, and in the background, we're going out to some undefined yet important streaming location, and we're bringing down the bits of the application on demand, right? So we're basically installing, if you will, this software on demand as the user requires it, right? Very fast. How long does it take to install Office? I don't know, 20 minutes? I haven't done it in a while because my copy of Office is virtualized. It comes down in a couple seconds. During Win 7 development, people in Microsoft are familiar with the term dog fooding, right? So while Win 7 is in beta, we were using the early builds, some better than others. And every now and again, you would get a build that couldn't be upgraded to. They would break compatibility. So you have to blow away your machine and start with this brand new install. So a lot of teams would grumble about this. Oh my God, if you blow a machine away, you reinstall Visual Studio, that's going to take 2 hours. Install Office. There goes Tuesday, right? The AppV team, we dog food AppV, 60 minutes or whatever to install Win 7. I don't know, 90 seconds to install the AppV client. One publishing refresh later, bam, there are all my apps. I have no fear of blowing away my laptop. So from a deployment standpoint, enabling these classic Windows applications to basically run as a service that's always available really, really lowers both the time and the cost of your software deployment processes. And the result of that is your IT and your operations, your deployments can be a lot more agile and respond to changing business needs a lot more quickly. And then finally, just to sort of tie this all up, we also provide a centralized management experience for these virtual applications, right? It's not enough to virtualize an application. It's not enough to make it available for streaming. You want to make sure that you're delivering applications to the users that need them. You're setting up the streaming points that are closest to the users that need them, so on and so forth. So we tie this all together with a single unified management experience. Ben, you told us you weren't a salesperson. Stop talking. Okay, I will stop talking. Okay, so we're going to identify the parts of the AppV management server, and by we, I mean you. So people in the room who are currently using the AppV management server, what are the major components that comprise the AppV management infrastructure? Go. Content share. Excellent. Management service, and by service you mean the web service. The Windows service. Both. Excellent. Console. Anything else? Client. Hey, I like that. The client. Part of the infrastructure, right? It's actually going to come up a couple of times when we talk about scalability because how you configure your client actually affects the scale of the management server. Love it. Anything else? Packaging. How you sequence your applications, right? Yep. All right. Not bad. C+. I'm a strict professor. What am I going to say? So I sort of group the components into two sets here. Inbox components, you don't buy AppV by going to Staples and getting it off the shelf, but inbox, as in the things that you would get. Had you done that and you remove the shrink wrap, what are the things that we deliver? And we pointed out all of these. That's great. There's the management server, which is the Windows service that someone was talking about. There's the management web service, which is independent from the management server, yet unfortunately named. We'll talk about that a little bit. And there's the management console, which is pretty much your administrative GUI. Then there's the other stuff. Someone said content directory, someone said the client. My list is a little biased here because I'm talking strictly about the things that are in the data center with the management server, so I don't have things like the client. But we do have things like the content directory, SQL Server database. No one said SQL Server. IIS, something needs to host the web service. PKI is only involved if you're using SSL-enabled RTSP. We'll talk about that a bit later. Active Directory, we use Active Directory to host all of our entitlements. Packages are entitled to Active Directory groups, so on and so forth. And I explicitly call out the network load balancing infrastructure. I mean, obviously, we're talking about network services, so all of your network infrastructure is going to be important here. I call it the load balancer specifically because it's going to come up in a couple of instances later when we talk about management server operations. So I want to make sure that it's on the list here in case anyone is going to memorize this slide and nothing else about this presentation. I want to make sure that's there. Yep. Forward. All right, so here it is in a pretty picture. So if we start from the top of that inbox list, we've got the management server here. What does the management server do? When a client needs something from the AppV infrastructure, it's talking to the management server most of the time, one exception. This is, as someone has already astutely pointed out, this is a Windows service. And I'll hop over to a server VM in a second. We can actually take a quick look at these components. Internally, if you take a look at it, and again, we'll take a look at this on the VM, it's a couple of different cooperating processes. And finally, the most important point here is that, I'll talk about this again a little bit later, the scalability form for the management server is scale out. We found in our testing that while scaling up, put the server on beefier hardware, you will be able to serve more clients. You can scale out almost indefinitely. Now, he just said indefinitely. I'm going to go home and try it. I tried 1 million users, it didn't work. When I say indefinitely, I talk about the hardware resources that we had available. We were able to get up to hundreds of thousands of concurrent users on 20, 30 servers, something like that. So apparently 2030 means indefinitely these days. I apologize. Web service. Management web service is a separate component than the web server, than the management server. Too many server and service terms bandied around here. Well, the management server is what the clients talk to. The web service is what the management console talks to. Okay? So the web service provides it's a SOAP-based interface, provides methods for adding packages, removing packages, doing the administrative tasks that the management console does. And the last point here is probably the most interesting. On my VM, you'll notice that I've installed absolutely everything on the same VM because that means there's less VMs to go wrong on the demo machine. But the web service is completely independent of the management server. So if you scale out to 15 management servers, that doesn't mean that you also need to scale out to 15 IIS instances of this web service. In fact, since this is completely driven by your management workload and not your client workload, it's quite likely you can get away with one instance of this off to the side with your management and operations consoles completely independent of your servers that are serving clients. Speaking of the console, here it is. Again, the console is an independent application. You're most likely going to deploy it on administrative workstations. You probably put it on your laptop. It's an MMC, so the interface should be pretty familiar. Again, it gets its job done by talking to the management web service and can be deployed independently. I already said that. Why did I say that twice? Database. This is the one that nobody mentioned, and this is a pretty important part. The database is the backing store for both the management server and the management service. So all of your package information, all of your entitlements, in other words, all of your associations that say you can have Office and you three guys back there can have Acrobat, all that information is stored in the database, along with whatever reporting information that we collect from clients out in the field. Active Directory. I call this out on the list here primarily because I stole this image from TechNet, because my art skills, even just using Visio, are terrible, and this is a convenient image. So I'll talk about Active Directory. Again, Active Directory is the source of all of our user and group information. We use the same directory information used in the rest of your organization, and it's read-only. A lot of applications write to Active Directory. They store their own sort of state and directory information within there. We don't. We're strictly a consumer of this information. Okay, and then the others. Others because they're not on that diagram, so I can't highlight them. Load balancer, again, I said I call it out specifically because the scale-out story for the management server is well suited to X machines in front of some sort of load balancer. Hardware box, no problem. Software-based NLB, also not a problem. We've done both. We've used Windows NLB ourselves, as well as a, couldn't tell you, hardware load balancer. As expected, no real surprises there. The content directory, which is actually the first thing that somebody pointed out, which is excellent. The content directory is involved in the server infrastructure, and this is what I said earlier was the one thing that the client talks to when it needs stuff that isn't the management server, right? So when the client needs icon and OSD information, it's not getting them, it doesn't contact the management server and say, hey, give me this icon. It's actually hitting the content directory. And when a client gets publishing information from the management server is really referring the client to, hey, this is where you can get the content for this information, which is typically the content directory, but can be overridden, and we'll see that a little bit later. So I originally wanted to make this another quiz slide. What does the management server do? And I figured by now you'd be tired of being quizzed for so much information. You're here to learn, not to be drill sergeanted. Is that a verb? I don't know. Anyway. This is what the management server does. We can break it down into 4 distinct operations. And really the first 2 are probably the most critical. You could argue that obviously you couldn't have an infrastructure without the other 2. I broke the clicker. But publishing and streaming are the most interesting. Redundancy. Fault tolerance. Publishing. Sorry, I broke a clicker. Publishing. Publishing is the mechanism whereby the presence of virtual applications is made known to your clients, right? So you've got a packaging infrastructure where you set up all these great virtual applications. You've got a client that could run these virtual applications if it knew where they were. Publishing is what ties those things together. Publishing is what tells the client, you've got Word, I want a shortcut on the desktop, the content is over there, the icons are over there. So pretty important. Streaming. If you think back to the sort of 2 pillars of AppV, you've got the virtualization and streaming. Well, streaming does streaming, no surprise there. Streaming is the mechanism whereby we can deliver the content of the application that was earlier published to the clients on demand, okay? And we'll talk a little bit more about when streaming happens, and what triggers streaming and what affects it in just a second. We know what metering is? Anybody? Shoot. Yeah, that's right. Yeah. So I originally had reporting here, because we all call it reporting. But if you actually look through the TechNet documentation, reporting specifically refers to the act of running a report, where metering is the act of gathering the information from the client, which is technically correct. But it meant that about an hour and a half before the PowerPoint submissions were due, I was furiously going through searching and replacing for reporting in some places and changing it to metering. So yes, metering is the process whereby we will go out to the clients, we'll collect the information from them about what apps have you been running, right? What's the state of your cache, so on and so forth. And then we'll aggregate that on the server for later consumption by reporting. And finally, management. Management is basically the nuts and bolts of what you do with the management console, right? This is package management, this is publishing packages, this is importing applications, this is changing entitlements, so on and so forth. So that's what they do. So those are the 4 things that we're going to focus on, okay? So enough overview stuff, get to the details. So in this section, we're going to take each of those 4 operations, and we're going to drill down into each of those in a lot more detail, see what each of them do in turn, and see what affects them in the infrastructure. And yes, I would love to reconnect. Thanks for asking. All right. Sorry. That's what I just said. I guess I should have clicked next earlier, but this is what we're going to talk about. Okay. First, a word on these terms, because they're related, but slightly different. So I want to make sure we're talking about the same thing. When we talk about performance, right, we're talking about something you can measure about some operation, right? So when I say what's the performance of a publishing refresh, right? I'm talking about a single instance, and I'm talking about something I can measure, right? So it might be, I clicked refresh, I started the stopwatch on my watch, and when I saw the icons appear on my desktop, I stopped it. Great, that's a measure of performance for that operation. When you talk about, say, metering, right? The process of the client sending this reporting data to the server. Measure of performance, it might be time. It might be how long does it take to upload this data. It could also be, hey, how much space do I need in my database to hold on to this, okay? So it's important to note here, when I talk about performance, I'm not just talking about what's the wall clocked impact of doing this, right? It's the total measurable impact on the entire infrastructure. Whereas scalability is, okay, as the usage pattern of the system changes, how does performance change, right? So performance is sort of a static measure in isolation, whereas scalability is, okay, well, given the performance is X when I do Y, when 9,000 people do Y, what's performance? Is it 9,000X? Is it X? That would be awesome. Just a quick word on that. So what affects scalability? We'll talk about specifics for the individual operations in a second, but a quick word on the types of things that affect scalability, because it's important to realize when you're talking about, hey, this is affecting my scalability, which of the about to appear 3 buckets it falls into will change how you address it, okay? First, I, for lack of a better term, call it architectural. These are, for the most part, things that you have no control over, right? Intercomponent dependencies, configuration that is hard-coded in the application. There's no knob you can go tweak to change it. That the management server needs to talk to a SQL Server database to do its job is an architectural dependency, right? It means that the scalability of the SQL Server is going to affect the scalability of the management server. There's really nothing you can do about that other than adjusting the SQL Server. Does that make sense? Removing the SQL Server from the equation is not an option. Sorry. Next are environmental factors. Yeah, these you have a little bit more control over. And these are what I think most people think about when they think about what affects the scalability of my solution, right? These are your hardware parameters. You know, what are the host operating systems? What am I running on? How much horsepower do I have? Are they chock full of memory? Big are the disks? How fast is that network? So on and so forth. I also include here configuration elements that you can change, right? What are the knobs and dials that I can turn to change the performance of the system, right? Finally, workload. I separate these from environmental because they're not necessarily technological elements, right? So by workload, I mean, when do your users show up for work? Do you have 10,000 people that all show up at 9 a.m. on Monday and all try to get a publishing refresh at the same time? Do they show up over time? How many apps do you have, right? The performance profile of a publishing refresh is going to be significantly different if you have 10 versus if you have 10,000. You may not have been needing to be told that, but it's worth calling out. And user distribution, again, when do people log in? What are they doing? How often do they launch applications? So on and so forth. So for each of those 4 operations, we're going to follow sort of the same model here, right? We're going to introduce them. We're going to talk about, hey, what's this for again? Briefly in review. When do these things happen? And how do we measure the performance? So like I said, remember, how you measure the performance of something is important, right? I can't answer, hey, is this scalable, if I don't know what metric you're using to say this is performing well. So I'll give you a recommendation of what we use to measure the performance of, say, a publishing refresh. Next, we're going to talk about what happens when I do one of these operations. I do a publishing refresh, what actually happens, okay? Talk to the database, we talk to AD, yada, yada, yada. Yes, I just yada, yada, yada in my presentation. And from that information, now that we know that all the components are involved, how they interact, we can actually identify, given this set of interactions and this set of components, these are the specific things that affect this operation. Okay? So before we jump into these, I'll stop briefly and see if anyone has any questions right now. I've tried to hold most of the questions till the end, just to make sure that we have enough time. But I also want to make sure that if you have a burning question that you had within the first 5 minutes of the presentation, I'm not making you wait 75 minutes to get it out. So anything before we dive into the operations here? No? Awesome. I also will apologize to the left side of the room over here. I will try to pay attention to you more. This is a very oddly shaped room. colleague of mine presented in, not this room, but the room next door yesterday, which is laid out the same way. And he said, man, this is the weirdest shaped room I've ever presented in. And I was sitting in the audience, like right in the middle here, staring at him. What's this guy talking about? Now that I'm standing up here, I'd like to revise my assessment of whether or not this is an oddly shaped room. So I apologize. I will try to pay more attention. Left side, have you met the right side? Great people. Okay, operation number 1, publishing refresh. What is this for? Talked about this a little bit already, and if you already use AppV, you probably know this. Publishing refresh is how people get the apps that they're entitled to, right? When does this happen? Anybody know? You can read the screen, but when does this happen? When they log in, right? The default configuration is whenever a user logs in, the listener, which is the service on the client machine, is going to trigger a publishing refresh. So as soon as you log in, we're going to make sure you get your current applications, right? So if your entitlements have changed while you've been logged out, it would be nice if you get those new shortcuts right away or those new file type associations as soon as you come back. Right? That's the default configuration. Every X somethings, right? So optionally, you can configure this to happen on an ongoing basis, right? So with the default configuration, that means if you publish a new application to somebody, right, you're not going to see it until they log out and log back in. Maybe that's fine. Maybe that doesn't suit your workflow. So instead, you could say, you know what, every hour, check for new apps, right? So now the story becomes, I publish a new app for someone, wait for at most 60 minutes. Okay? There's a third option that I didn't list here. Anyone know what the third option is? Yeah, whenever you want. There are buttons you can click to say, go refresh right now, right? So we'll take a look at those in a second. How do you measure the performance of a publishing refresh? Well, we say that the best way to measure the performance of the publishing refresh is how long does it take from the time the refresh starts to I see my new apps, right? So if this is the first time I'm refreshing, right? Just installed the AppV client, I'm rebooting, I've never gotten any apps before. I log in for the first time, right? By the time I finish entering my password and hitting yes, and I see my desktop, till the time that Word shortcut shows up on the desktop, that's a measure of the performance of the publishing refresh, right? Same thing with the apps that have been published on the fly during the day, right? If I have to wait till tomorrow to log out and log back in, that's a measure of the performance of the publishing refresh, right? I'm trying really hard not to break this one now. I'm like cradling it as I walk. It's very concerning. So what happens in the server infrastructure when you do a publishing refresh? All right, server gets this request from the client. First thing it does in that request, the client will have included its authentication token, right? We're going to turn around, we're going to throw that authentication token to Active Directory and say, hey, Active Directory, what groups does this guy belong to, right? Because entitlement is done to groups, right? Applications are assigned to AD groups. So we need to figure out, okay, well, you're asking for applications, I need to figure out what groups you're in, right? Okay, now we have that information. We go to SQL and say, hey, SQL, give me all the applications on the system. I need everything. Then I'm going to take the groups that you belong to, and I'm going to pare that list down to only the things that you're actually entitled to. Okay? So now that I know what groups you belong to, now that I have all the applications in the system and who they're entitled to, I can use that information to pare that down to just the things that you have entitled to you. I'm going to return that to the client. We done? No. As this gentleman pointed out, content directory, very important. Once the client gets that information, it's going to turn around, and during the act of publishing, it's going to reach out and contact the content directory to get new icons and OSDs as necessary. Right? So even though from the management server's point of view, at this point the refresh is done, the infrastructure is still involved because the content directory is still going to be involved too. Okay? Okay. What have we found to be the biggest things that affect publishing refresh? By far and away, we found that the biggest thing that affects the performance of an individual publishing refresh is other publishing refreshes. Okay? The runtime activity of paring that list down, of taking the list of applications and applying the entitlements, getting the condensed list, making a nice XML document out of that, and throwing it to the client is pretty CPU intensive. We're not talking about doing one of these is going to peg your CPU, but all other things considered, that's the thing that tends to be unbounded first, right? So really the volume of refreshes that are going on right now is the biggest contributor. And a close second is, well, if that's an expensive operation, sort of merging those two lists, smaller the list is, you'd think it would be faster, right? You would be right. 10,000 applications, a lot less time to build the list of entitled applications for you than a million. Right? I went the other way. You thought I was getting smaller, didn't you? Next, SQL Server capacity. If you remember, the operation takes a dependency on SQL Server, right? We need both the list of applications and we need your entitlements, right? So both of those are going to represent a query from the management server to the SQL database, okay? So indirectly, the volume of publishing and refreshes that are going on are going to directly, indirectly they're going to directly, but they're going to imply activity on the SQL server, right? So once you've sort of worked out enough CPU capacity on the management server or servers, if you're scaling out, to deal with the operational complexity of making this combined list, you need to make sure that SQL Server can actually handle the amount of queries that are being thrown at it. Generally not a problem unless you're using a non-dedicated SQL Server, right? If you're using a SQL Server that hosts a lot of applications, you may not have complete control over what's happening on that SQL Server at the time the management server is trying to get this information from it, right? So something to keep in mind. You may not actually have the luxury of deploying one SQL Server per application farm that needs a SQL server. So something to keep in the back of your head. Sorry, left people. And finally, the content directory, which we talked about very briefly already. We've seen publishing refreshes, the interaction with the management server finish in lickety-split, no time at all. And then the client takes forever to publish the icons and shortcuts. Why? Content directory is slow, right? So don't forget to take the latency and the capacity of where your content share is into account when you're gauging the overall performance of publishing refreshes. Because remember, the user's point of view, what we're using to measure the performance is how long does it take to see my stuff, right? So you can put the management server on the beefiest box you can find and you can deploy 20 of them. Content directory is that beat up 486 over there that happens to be running Samba for a file share. End-to-end experience may not be all that great. Okay? Let's see here. We have some demos for that. I did say earlier I didn't go to any of the parties last night, though for whatever reason when I laid out my notes for this presentation, I also laid out my Weston build. I don't know why that's an important part of this demonstration. But anyhow. Okay, so see. It's enough PowerPoint. Let's see some stuff. So I said that one of the most, or the most important factor is the volume of publishing refreshes, right? So how do you control that? Well, above and beyond the workflow issues, right? So if you have the flexibility to control when your users are actually doing publishing refreshes, you can indirectly affect the hit on the management server, right? So I want to review quickly those settings that I talked about that control when publishing refreshes happen. So this is the client management console, right? This is the point of administration on the client. And here are the publishing servers that we have set up, right? And I have a single publishing server, which is that other VM you can see down on the taskbar. Cleverly named app vserver. If we look at the properties for this, you can see those two settings that I was talking about, right? Refresh on login, refresh every X whatevers, right? So if you can't control when people are logging in, right? And the frequency at which you publish more applications, right, isn't such that not having a refresh on login is going to cause a poor user experience. Maybe you would consider saying, well, you know what, I don't want to do it once per login, but every X hours is fine. What have you. If neither of these is interesting to you, there's always the manual option, right? So I don't ever want to refresh manually, but either from management console, I can say, please refresh now, or if you're a command line kind of guy, familiar with SFT mime. SFT mime, anyone? Everybody knows SFT mime? Great. Refresh server, and it was called, I believe, app vserver. Bang, publishing refresh. Just to prove that it's not smoke and mirrors, we'll delete Orca. Do it again, publishing refresh, Orca comes back. Great. Good time was had all around. On the server side, now anyone who listened to my description of how the publishing server handles a publishing refresh, any red flags go up? Anyone say, oh my God, why does it do that? Nobody? never mind. Everything's great. I'm just going to move on to the next topic then. How often does your application catalog change? How often do you publish new apps? Anybody? Once a week. Once a week. Anybody less infrequently? More frequently than once a week? Every day? Okay, once a day. Okay, so if most people publish new apps once every 24 hours, why on earth would the management server ask the SQL Server for the entire list of applications every time someone wants a publishing refresh, right? So the likelihood that it's changed seems pretty slim, right? Probably figure out the function if we really wanted to, but the answer is a really small number, right? So that seems pretty inefficient. And there's a parameter you can use to control that. So I actually lied a little bit when I talked about the workflow there. We don't actually hit the SQL Server every time we get a publishing refresh. The server actually caches that information internally. Each of the cores, the server has multiple server cores. Each of the cores caches that information for some fixed amount of time, okay? The default's 3 minutes, okay? So at most, we'll go back to the SQL Server every 3 minutes to get an updated list of applications to figure out what you're entitled to, okay? Well, what does that mean from a user perspective? Well, it means that if you're really, really fast and you publish a new application and you turn around and refresh immediately, there is a window of up to 180 seconds where you might not actually see it because the server that you're talking to hasn't decided to refresh its SQL cache yet. On the flip side, the management server is not hammering your SQL Server, which seems like a good thing, right? That said, maybe even once every 3 minutes is too much. Maybe you're like, it's every 3 minutes. Are you kidding me? Once an hour, right? It's plenty of time. There's a configuration parameter on the server you can use to control that behavior, which again, don't feel like you need to memorize these. There's a list at the end of the presentation that I will not reread to you. That's not how you spell regedit. That's how you spell regedit. All right, here in the 4.5 server, you can make a dword value called DC cache timeout. Anyone know why it starts with DC? It's another old soft grid aphorism. All right, never mind. Maybe I want this to happen every, whatever that works out to in minutes. That's in seconds, right? That's how you can sort of control how often the management server is hitting your SQL infrastructure. All right, enough about that. So that's publishing. Package load. Oh, yeah, we're done. Not too bad. When do you load packages? And what is loading a package? Well, loading a package is delivering enough of the package to the client so the client can actually launch the application, right? And I say that specifically, not delivering the package to the client, because if you're familiar with the sequencer, virtual packages have a couple of different sections within them, right? There's what we call the launch data, or if you remember old terminology, feature block 1, which is everything that the sequencer decided, this is what you need to get up and running quickly, right? This is the minimum set of information you need to launch this virtual application, right? So if you've sequenced your package and you've gone through the step where you launch the applications first and you've set up a first feature block, when you launch an application for the first time, that's all we're going to load, right? So when we talk about when do package loads happen, well, the first time you launch an application, we're going to load feature block 1, right? When else do we do package loads? Well, as you're using the application, let's say you're using Word, right? And we've only streamed 1% of the package. You go to bring up the spell checker. Spell checker is not in that 1% of the package. What's going to happen, right? Background, the client is going to go out to wherever the streaming source is. It's going to pull down the bits that you need on demand, and the user is going to see the application just bring up the spell checker, as you expect, right? This is that network available software as a service sort of element to the streaming infrastructure. And then finally, you can configure the client to say, well, you know what? These applications are pretty important, but I still don't want to make the user wait for them on that first application launch. I'm going to configure the client to automatically load things in the background, right? So I still only need this tiny slice of Word to launch my Office package. But once I've done that, over time, during spare cycles, the client's going to go out and try and bring down the rest of the Office package, right? So maybe the next time I launch the package, it's completely loaded in the cache, and now comes up really fast, and all the features are instantly available, right? So how do you measure the performance of these things? Well, obviously, to load feature block 1, how long does it take to launch the package, right? So between the time that I double-click on that Word document and the time that I see Word, that's how long it takes to load feature block 1. So that's how I measure the performance of that operation, right? For out-of-band requests, right, for application usage when I need to go out and sort of pull down bits of the application on demand, really need to measure that in sort of vague terms and the responsiveness of the application, right? So if I go, like in my earlier example, I go to start the spell checker, and it takes 10 seconds. Poor performance, right? The user interface guidelines say, what is it, anything longer than, what is it? 100 milliseconds is noticeable. 1 second, you're likely to go do something else, something like that. So measuring how we sort of do this on-demand streaming is best done in terms of how responsive the application feel, right? Does the user say, hey, it's worse when I use the virtualized version than when I use the natively installed version? As far as auto load, you really can't measure what's the performance of doing something in the background. You really need to measure, does this impact the system at all, right? So while I'm sort of in the background loading this extra information that I may not necessarily need right now, am I adversely affecting other things that are happening on the system, right? All right, what happens when you load a package? Well, we authenticate the user if you're configured to do so. Make sure that the user is authorized to access the thing that they want to access, right? So another round trip to Active Directory. Load the content and deliver the content to the server, to the client. Deliver it to the server. That's a round trip, isn't it? That's it, right? So 2 hits to Active Directory, and we're going to blast some data down to the client. What affects the scalability of that operation? Well, I don't have it listed here, and it probably goes without saying, the speed of the link between the server and the client probably is going to be the most important thing that affects this operation, right? So you're on a 56K line, it's probably not going to be all that performant or scalable. I hope that's not true for anybody. Okay. So other than that, feature block 1 optimized packages. When you do your sequencing, that step where it says, hey, do you want to launch these things for the first time to optimize for streaming? Huge impact here, right? Let me show you an example. Over here on my client machine, I've got my good friend Orca. If we look at the properties of the Orca package, you'll see that the entire size of the package is 3 megs, right? The launch size, or feature block 1, because feature block 1 is an antiquated term, it's about 200K, right? So I need less than 10% of this package to actually launch it for the first time, right? So I only need to download 10% of this to launch it for the first time. Clearly, I'm going to have much better performance on first application launches if this package was optimized for streaming. If I hadn't done anything and the launch size was 3 megs, you're going to need to wait for that whole 3 megs to be downloaded for the app launches. 3 megs, no big deal. You're probably right. Visual Studio comes in at about 4 gigs, right? Long time to wait for a download if you just want to launch dev app, right? All right. Enough about that. Apologize for the jarring transition there with the screen. I'll try to jump back and forth less. Load balancing, I bring up load balancing not necessarily because it has an impact on scalability, but there's something you need to take into account here when you're using load balancing in front of RTSP servers. When a client makes an RTSP session connection to the server and it wants to stream something, there's actually multiple independent TCP connections there, right? So the connection over which we do the authentication exchange and the connection over which we stream down bits of data, 2 separate independent TCP connections. Well, why is that important? If you don't have your load balancer set up to, and people call this different things depending on the load balancer, to use the sticky setting, right? You can have this situation where the client will talk to one server to do its authentication, and then it'll talk to some completely different server to stream information, and the server will say, who are you? I've never heard of you, right? So you need to make sure that for a given client, requests from that client are always routed to the same machine, right? And there's usually a setting in your load balancer where you can make sure that based on MAC address or IP address, whatever, some sort of token, packet inspection, and make sure that all the connections from the same client are going to the same machine. That's great, but in some small effect, that sort of defeats the concept of load balancing, right? Or at least it changes the profile of how your connections are balanced, okay? Make sense? Everybody? Okay. Significantly more important on a TS box, if you think about it, right? If you're enforcing all of the connections from one machine to go to a specific server, well, TS box could have 30, 40, 50 users all streaming at the same time on it, right? And finally, the auto load settings, which you sort of touched on already briefly. hop back over here and show you where those are. Obviously, if your packages are set to auto load, subsequent launches are going to be faster. In practice, we haven't really seen a lot of impact to concurrent operation on the client machine while auto loading is happening. We try to only do our auto load operations during idle times when we sense that nothing else is going on. The thread that does that runs at a pretty low priority. So there should really be no effect to other operations on the client while this is happening. You can set this up at install. Otherwise, there are these two settings here in the registry where you can control what triggers auto loading to start, right? And what things do you auto load. I don't remember what those bits mean, sorry. But at the end, there's a reference to TechNet. All these things are documented. And is a much better reference than I am. All right, that's package load. Rest of these are pretty straightforward. Application launch, I call this out separately than package load because I'm talking about subsequent application launches, right? So let's say package is fully loaded in the cache, right? 100% loaded. There's no need to stream anything. By default, the client is still going to reach out and try and contact the server to do authorization, right? Still going to make sure that you're entitled to use this package, okay? So there you go. Ensures user is authorized to launch package. When does it happen? Before each virtual application launch. Technically happens on the first launch too, but we covered first launch when we talked about package load. Yeah. Performance, again, how long does it take to launch this application, right? It takes me years to authenticate somebody, then I'm not going to be super thrilled. If this workflow looks the same as it did at the beginning of package load, that's because it is exactly the same as what happens during package load. We just stop before we actually come up with any bits to deliver to the client, okay? Get a token, query AD to see who you are, query AD to see, hey, we know who you are, can you actually touch this thing? Again, I bring the note here about network load balancing simply to make you aware of the fact that we're using separate connections here, so you need to make sure that connections follow the target machine. Disconnected operation. Obviously, authentication requests are going to be going to the client if your clients are running in online mode, right? If you have mobile clients, you have clients that can and do go offline, that's something that you can use, that's a factor that you can use to control the amount of authorizations that are happening for cached application launches. Since mobile clients are the ones that are most likely to have fully cached applications. Otherwise, they're offline, they can't get to the corporate network. Obviously, they can't stream anything, so they better be allowed to run in offline mode, right? And the volume of concurrent requests. Since these involve multiple round trips to Active Directory, the distant third here is the volume of requests that are going on. But we've yet to find a scenario in which Active Directory is the bottleneck in any app management server deployment, ever. Do not take that as a challenge to go back and try and find one, please. I don't like when that happens. Metering. What's metering? Someone has already defined that for me. Thank you very much. Metering is the process whereby the client records activity, application launch activity on the client, and then during a publishing refresh, right? First thing it does is it reaches out to the server and says, hey, give me my new publishing data. Great. Second thing it does, send you my metering data, okay? So first, we download the new publishing information. When that succeeds, client uploads its metering information to the server, right? So frequency, completely dependent on when publishing refreshes happen, right? You can't really, there's a way you can do it, I'll tell you later. You can't actually separate these two workloads. So a publishing refresh, what's a publishing refresh? Publishing refresh implies a metering data upload. So all of the earlier guidance around controlling when publishing refreshes happen apply to metering data uploads, right? And how do you really measure the performance of this? In and of itself, since it's part of another background operation, you really measure its performance in terms of how does it impact performance of other operations, right? On the server, as we'll see in the next step, a lot happens when you upload this metering information. And not only does a lot happen, it's a lot of different stuff, right? So metering data uploads can tend to have downstream effects on other operations that the server is doing, and that's really the best way to measure the performance. All right, what happens when the server gets this information? To summarize this slide, a bunch of inserts into SQL, okay? We record the client, we record information about the packages in the cache of the client, and we record information about the launch history in a table in SQL. Right? What affects this? Well, what affects the SQL usage? Well, obviously it's the volume of data, right? And the two main triggers for what's the volume of data, how often are you doing publishing refreshes, right? That's going to control the frequency of these uploads. And then on the client, the client workloads are going to be contributing to this too, right? If you launch, if you come in like I do, you launch Outlook at the beginning of the day, you launch Product Studio, which is my bug database, at the beginning of the day, you launch your editor at the beginning of the day, and you never launch another app again. You never close them. Not a lot of data to report for me, right? If you're constantly starting and shutting down applications, that's going to imply a much bigger set of data from the client, right? So how your users actually use their applications is going to contribute to the volume, and therefore it's going to contribute to the overall scalability in terms of how quickly is your SQL Server going to grow, right? Makes sense, right? Again, indelibly tied to publishing refreshes. You can't really separate the two workflows. And then indirectly to the volume of data, what's your SQL Server capacity, right? We can jump over here to the server really quickly. Is that the server? Yeah, that's the server. And way at the bottom here, this is the server. Whoa. All right, if we look here in SQL, application usage. I have exactly one record in my application usage table. I suspect that you have more. Right. If we come over here to the client, and we take a look in program data, what the client's doing is, as applications are being launched, it's recording each of these launches in this offline XML file here. We pop it open in everyone's favorite notepad, currently empty. Right? I haven't launched anything since my last DC refresh, which was that manual one I did from the command line about 27 minutes ago. Right? So let's launch something. Orca. Everyone loves Orca. Goodbye, Orca. Look at the file now. Hey, look, he's launched Orca. Right? So basic information about who the user was, when did he launch it, when was it shut down, what was the package, so on and so forth. Right? If I refresh the server again, because remember, metering data uploads are tied to publishing refreshes. So if I do a publishing refresh, look at this document again, one hopes it's empty. It is, because the data's been uploaded to the server. Come back over here, another application launch record for Orca, right? Pretty straightforward, but multiply that by X thousand, and that's what's happening in your environment, unlike my demo laptop. All right. Home stretch. Management. I'll preface this by saying, for the most part, management operations aren't a scalability concern, except for one or two really isolated incidents, and I'll point those out. What do I mean when I say management? Basically, anything you do through the management console is management. Okay? Adding packages, entitling packages, running reports, so on and so forth. When does it happen? Completely up to you. The management console does nothing independently. Right? It doesn't act. It's not an active agent. It's completely 100% driven by business need. If you need to add a package, right? No background processing that's happening here. And again, what's the performance? It's another interactive application, so we're talking about the interactive profile of user applications. As you were. Most of the operations take the same form, right? They talk to the web service, say, give me some information. Web service talks to the database, turns that information up to the client. Management console does something, where something is defined by what were you doing? You got managing packages, were you changing entitlements, were you running reports? And then finally, the console turns around, asks the web service to perform some update. I want to add this user to this package. I want to delete this package, so on and so forth. And that's recorded in the database, right? Very common query, update, save. Database profile operation. By far and large, the biggest thing that will contribute to poor performance of the management console and therefore poor scalability behavior of the management console as your infrastructure grows is your package profile. As you add packages, the performance of the management console is going to be visibly affected, right? Tens of thousands of packages. It's going to take a long time to refresh that pane where you see, here are all of my packages, right? A couple of reasons for that, right? A, it's just a long time to load a lot of things in that MMC view. We've got to go out and get all those icons again from the content share. So again, the latency of the content share is going to be affecting this. And really complex packages magnify this effect pretty significantly. Anybody have any packages that have over 100 individual OSDs? No. Anybody think that that's an odd thing to do? No. Okay. How about applications that are entitled to over 100 different AD groups? Not 100 different people. I mean, obviously that works, but 100 different groups. No. Okay. All right, you're in the clear. Don't do those things. And then obviously SQL Server capacity, particularly around reporting. Running reporting can be a pretty intense operation, just the volume of data we're moving around, the complexity of the queries that we're performing. So if you're going to be running reports while other activity is going on in the server, and you have a really, really large volume of data to work with, you have a large infrastructure, a lot of packages, a lot of clients, really consider trying to do that off hours. Or, yes? You can, and so the actual recommendation I'll talk about a little bit later. Yep. But yes, so the question was, should I actually then set that up as a separate instance? So from a pure best practices standpoint, right, absolutely, right? It's rule one of data warehousing. Separate your transactional store from what you're actually using to run reports on. I'll talk a little bit later about how you can set that up. Although a little bit later is now because we're almost done. The blinking red light tells me so. Okay, so those are the operations. That's all the management server does. It really doesn't do anything else, okay? So to tie this all up, I'm going to augment this with a couple of recommendations, reinforce some of the things we already talked about. A couple slides here I'm just going to jump over because, like I said, it's mostly information to take back with you to refer to later on. There's no point in me sitting here and reading numbers and walls of text to you. Take them, read them, digest them on their own, and apply them to your own environment. So I'll show you some sample deployment figures. I'll talk about some of the test infrastructures that we've used, what were the machines, what were the numbers we were able to drive. Sort of give you a starting point, right? It's one thing to say, hey, go test your own environment. But if you don't know where to start, do you need one server for tens of users, hundreds of users, thousands of users? So again, while the solution for your environment is going to be custom to your environment, and you really should test this in your own environment, I'll give you a place to start, right? I'll give you a reference point that I can tell you, well, we know this works, right? Start here and build on that, right? Again, this is there'll be a reference for all the configuration parameters that we talked about earlier, as well as a couple that I didn't jump into because you can only take so much reg edit. A couple of additional deployment options, things you can do in addition to using the management infrastructure, and one of those is going to be an alternate reporting solution, like you asked about. A couple of tools, some resources. So deployment figures are going to follow. This is the machine spec that we use based on the OS. You can see that this test was from a couple of years ago. It's not R2, it's Windows Server 2008. These same numbers can be found in the AppV 4.5 server sizing guide, which is available online. There's also a link to it at the end of the presentation. So I'll just jump over these. But again, in terms of summary, when you're talking about publishing refreshes for a single server, you're talking about multiple thousands per minute concurrently. Right? For package load, at least in our environment, by far and away the limiting factor was found to be the bandwidth of the network. Right? We couldn't actually get a scenario set up where we could have a fat enough pipe to our management server where something else became the problem for package loads. Right? Again, you can review these later. This is just a summary table. The information in the sizing guide includes these numbers along with some more information about the environment we used, how we set them up, and how we conducted the test. As well as performance figures. Here's an idea of the impact that various things have on your SQL Server database. You're trying to figure out what size do I need to grow to. These are the max sizes for each of these things. Most important one here, I can probably point to it, that metering upload, right? So application usage, by far and away, is probably going to be your biggest driver of database size. Just to sort of reiterate some of the things I talked about a couple minutes ago, understand how your users are using your system, right? When are people logging in? Does logging in imply a refresh? How frequently are you publishing new applications? How quickly do your users need those new applications after you've published them, right? How many applications do they launch? Do you have auto load set up, right? Are your packages feature block optimized, right? How many applications do you have? How many packages? How many applications per package? So on and so forth. So again, a summary of just the things that we've already sort of covered earlier. Administrative, from the management console, how often do you do these things? Because they're going to have downstream effects on the earlier questions. And hey, can you run that report later? Really, really worried about breaking this clicker. 2 minutes left. I'm afraid I'm going to click it. I'm not going to read this to you. This is a summary of all the configuration parameters we talked about earlier, along with 1 or 2 others that we did not. For example, the ASR, ISR, OSR, links to where you can find more information about those. These are the points on the client. These are points on the server. We didn't talk about the last 3 here, but by far and away the easiest way to make any of these operations scale, turn them off if you don't need them. Not interested in reporting, you can shut it off. TC cache timeout we talked about. Additional deployment options. So if in analyzing your deployment, you find that maybe your publishing workload is fine, but streaming is the bottleneck, right? Love the management server, favorite piece of software. We've tested it to scale to impressive numbers. Maybe that's not the right answer for you, right? Maybe you have remote branch offices and they need a local streaming source, right? The answer isn't always a central management server infrastructure, right? So a couple of options to consider for addressing operations that the management server could perform, but other ways to perform those, right? Alternate streaming sources. AppV provides a streaming server, which is a stripped down RTSP server, which is only the streaming components of the management server, right? You can deploy those at remote locations. You can have a streaming source. You can handle content needs for your users at other locations without implying a hit on your central management infrastructure, right? File streaming. Streaming server too complicated? No problem. Point your clients at a file share, call it a day. Use some sort of replication, DFS, get the files out there. Simple, ready to go. HTTP streaming and reporting. There are a couple links at the end in the resources section that'll give you more information here. Basically, as of 4.6, it's actually earlier in 4.5, but I'm going to say 4.6. As of 4.6, the client supports uploading its reporting data to an HTTP server instead of to an RTSP server. Earlier, it would only ever upload its reporting information if it saw that it was talking to an RTSP management server. So if you want to hang around a little bit afterwards, I can give you some more information about this. If anybody else is interested in HTTP reporting, I can point you at the docs. But basically, we found that the HTTP reporting upload to scale to millions of uploads per minute, by far and away more than you could handle with the management server. So if you're concerned about massive volumes of reporting information, this might be the answer for you. Finally, SCCM. If you're already an SCCM shop, you've got an infrastructure for delivering applications to your clients, certainly use it. SCCM's integration story with AppV is really great. 2007 R2, a lot of interesting stuff coming in 2012. If you go down to the floor, go to the SCCM booth, I'm sure they'd be happy to give you a demo. If not, don't tell them I sent you, sorry. That's it. A couple of helpful tools to analyze what's going on in your infrastructure. Probably nothing here is a surprise to you guys. Again, resources, server sizing guide is there, TechNet, IPDs, HTTP publishing and streaming. That's it. We're done. Look it up. That's all. Proof that I use this stuff.